Well, hello, my students. I hope everything's going okay. But I thought now it's time to get back to going, seeing how things are. We're going to look at circles. Now, circle might be the easiest thing to deal with the graph. You need a point on the Cartesian coordinate system to start with. For a circle, then you need the distance. So let's say this is the point. Then you need to know how far from that point is the circle. You get a mathematical instrument to measure it. Then you go all the way around with the same distance. That is horrible. Sorry about that. Can't draw a circle too good. Now, in the olden days, I would just take a pen with a piece of string, but that's hard to do on and videotape it. So then, this is called the center of the circle. The distance from the center to a point on the circle is called the radius. And if you connect the radius and go all the way across with that segment, that's called the diameter. So it has an end point on each part of the circle. Went a little bit farther. So those are the three words you really need to know for this class. So you got the center, that's the point where the circle comes from. Now the center is not on the circle. This is the circle right here. It's the distance from the center, and you go that. So this is centers inside, and then points out here would be outside. Inside, outside. Wait, let's stop. This is brought to you by Girl Scout cookies. Let's look at some. Uh-oh. Okay, it's brought to you by boxes to put stuff in. Need those boxes. Okay, here we go. Find the center and radius of a circle. So a circle on a Cartesian coordinate system is made up this way. X minus h squared plus y minus k squared equals r squared. And there's two things we're looking for. The center and the radius. Take a wild guess and say it out loud, because I can't hear you too well. What do you think the center is, knowing what we know about the other graphs? That's right, very good. So it's HK, just like the vertices. Now, gee, this is r squared. What do you think the radius is? That's right, r. Boy, you guys are smart. So I call this the cur, or if you want to go with a silent C, sir. So find the center and radius. The center would be 3, -2. And the radius is the square root of this number. Hoo-hoo. Oh, I don't know why I put parentheses there. Square root of 100 is 10. So if I wanted you to graph this, but normally I don't have a graph circles. There's not much to it, and it's hard to do without mathematical instruments. You go to the point 3, -2, and then go 10 units out. Woohoo. If I did have you graph it, I would have you do this. I would go, 3, -2, 3, -2. Then I would have you draw dots 10 units from it, up, down, left, right. Someone should have picked smaller numbers. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here, then 10 this way, 2, 4, 6, 7, 8, 9, 10. 10, oh gee. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good land. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then just curve. Oh, look at how, oh my goodness, if that doesn't look like a circle, I don't know what does. This is a 6 circle. So that's why I don't tend to have to draw it, because that looks horrible. But what's the center and radius? The center would be 2, 0, just like the vertexes, and then the square root of this number. So radius is 2 square root of 2. So let's flip her over. Now, how do I get this in proper form? I need to get this, square. This is a square. How do I take a polynomial and take it as a square? I just don't know. Complete the square. You guys are so wise. Thank you. So half of 6 is 3. 3 squared is 9. So remember, I got to add 9 to this side. Then half of 4 is 2. 2 squared is 4. So I have to add 4 to this side. So I would have, factor this, x plus 3 squared plus y minus 2 squared equals 16. So my center would be negative 3, 2. Put a dot there if I asked you to graph it, but I didn't. And the square root of 16 is 4. Now let's go in reverse. Given a center and radius, can you find the equation? Well, sure. It's x minus the x number squared plus y minus the y number squared equals the radius squared. Easy peasy chocolate cheesy. So here's another problem. Turn off me and do it, and then turn me back on. Okay, good. So it's x minus the x number squared plus the y minus the y number squared. And if I'm not writing this well, I just poked myself in the eye by mistakes. I can't see out of my right eye, so I'm trying. 3 squared is 9. Square root of 2 squared is 2. 9 times 2 is 18. If you got that right, good for you. Now, given the endpoint of the diameter is 3, 4, and 7, 12, find the equation of a circle. Well, remember, the diameter goes through the circle. So I'm saying that one of these is 3, 4, and the other one is 7, 12. So I need to find the center. But wait a minute. Remember, this is a radius, this is a radius. There's 2 radiuses in the diameter. So this has to be the midpoint of this and this. I know how to find the midpoint. Oh, Murphy, you're so fine. So the center is the midpoint of the 2 endpoints. So we'd have 3 plus 7 divided by dose. Oh, I messed this up. Start over. 3 plus 7 divided by 2, comma, boy, my eye hurts. 4 plus 12 divided by 2. So my center is 10 divided by 2 is 5. 4 plus 12 is 16 divided by 2 is 8. So I know part of the equation. X minus 5 squared plus y minus 8 squared. Okay, now I got to find the radius so I can square it. So I know the center is, what did I say, 5, 8. So there's 2 ways to do these problems. I could use the distance formula to find the radius. That would be fine. So distance formula, it'd be 7 minus 5 is 2, squared is 4. 12 minus 8 is 4, squared is 16. So it'd be the square root of 20. So the radius is the square root of 20, which square root of 20 squared is 20. That is fine. Or, here's another way they like to do it in upper level math. To be an endpoint means it has to be on the circle. So this is way number 2. You choose which way you want to go. I don't care. So, if an endpoint's on a circle, it means when I put it into the equation, it causes it to be true. So what I can do is take the center part of the equation and plug in an endpoint and see what I get. So one of the endpoints is 7, 12. I think that's what I said. Isn't that what I said? Yep. 7, 12. So I'm going to put 7 in here, plus 12 in here. And notice, 7 minus 5 is 2. 2 squared is 4. Plus 12 minus 8 is 4. Squared is 16. That has to be what the equation equals, because the endpoint is on the circle. It caused it to be true. So therefore, this is my answer. So see if you can do it with this one. It's tricky. So we know that the endpoint is 2, 8. And it's 420. So I know my center is the midpoint, which would be 4 plus 2 is 6, divided by 2 is 3. 8 plus 20 is 18, divided by 2 is 14. So I know that my left side of the equation is x minus 3 squared plus y minus 14 squared. So I have two choices. I could find the distance of one radius. That would be fine, which would be 4 minus 3 is 1. 1 squared is 1, plus 20 minus 14 is 6. 6 squared is 36. So the radius is square root of 37. This is the radius squared. Or you could say, wait a minute, the endpoint has to cause this to be true, so put it in the left side of the equation. So it'd be 1 squared is 1, plus 20 minus 14 is 6. 6 squared is 36. So it has to be 37. So, ooh-hoo-hoo. So, hoo-hoo. That's our circle. Have fun.